Right now, at this very moment, somewhere in our galaxy, a star is being born. Not in a hospital, not on a planet, but inside a massive swirling cloud of gas and dust so large, it would take light itself hundreds of years to cross from one side to the other. These clouds are called nebulae, and they are literally the birthplace of stars. Every star you've ever seen in the night sky, including our own sun, was born inside one of these cosmic nurseries billions of years ago. Today, we're going on a journey inside a nebula to witness one of the most beautiful, violent, and awe-inspiring processes in the entire universe, the birth of a star. Before we witness a star being born, let's understand the stage where it all happens. The word nebula comes from the Latin word for cloud or mist, and that's exactly what they are. Enormous clouds of gas and dust floating through space. But don't let the word cloud fool you. These aren't the fluffy white clouds you see on a summer afternoon. We're talking about clouds made mostly of hydrogen and helium, the two most abundant elements in the universe, along with traces of other elements like carbon, oxygen, and nitrogen. And the scale, absolutely mind-bending. The Eagle Nebula, one of the most famous, is about 70 light-years across. That means if you traveled at the speed of light, 300,000 kilometers per second, it would still take you 70 years to cross it. There are different types of nebulae. Emission nebulae, clouds that glow with their own light, energized by nearby stars, reflection nebulae, clouds that reflect light from nearby stars like cosmic mirrors, dark nebulae, so dense they block the light behind them, appearing as dark patches in space, planetary nebulae, shells of gas thrown off by dying stars, and most importantly for today, stellar nurseries, the specific regions inside nebulae where new stars are actively being born. These stellar nurseries are where our story begins. For millions, sometimes billions, of years, a nebula just floats through space, slowly drifting, doing almost nothing. So what breaks the silence? What triggers a star to form? In most cases, something violent. Trigger 1, a supernova shockwave. When a nearby massive star dies in a supernova explosion, it sends a powerful shockwave rippling through space. When that shockwave slams into a nebula, it compresses the gas, squeezes it, and that compression is all it takes to start the process. Trigger 2, galaxy collisions. When two galaxies collide, the gravitational forces compress huge clouds of gas, triggering massive bursts of star formation across entire galaxies at once. Trigger 3, spiral arm density waves. As gas clouds orbit through a galaxy's spiral arms, they get compressed by density waves, like a slow-motion cosmic traffic jam. And that compression triggers collapse. In each case, the result is the same. A region of the nebula becomes denser than the rest, and once that happens, gravity takes over. And gravity, as we'll see, is absolutely relentless. Once a dense region forms inside a nebula, something inevitable begins. Gravity starts pulling the gas inward. At first, it's slow, almost imperceptible. But as more gas falls toward the center, the density increases. And as density increases, gravity gets stronger, which pulls in more gas, which increases density further. It becomes a runaway process, a feedback loop that can't be stopped. Scientists call this a gravitational collapse, and it's one of the most powerful processes in all of nature. As the cloud collapses, two things happen simultaneously. First, it heats up. As gas particles fall inward and collide with each other, they release energy as heat. The center of the collapsing cloud, called the protostellar core, begins to warm up from near absolute zero to hundreds, then thousands, then tens of thousands of degrees. Second, it spins faster, just like a figure skater pulling their arms in to spin faster. As the cloud collapses inward, it begins to rotate more and more rapidly. This spinning is crucial. It's what gives the future star system its shape. The collapsing, spinning, heating cloud of gas now has a name: a protostar. A baby star has entered the universe, but it's not a real star yet, not even close. The protostar sits at the center, growing, feeding, getting hotter and denser by the day. Around it forms an accretion disk, a flat, swirling disk of gas and dust orbiting the young protostar like a cosmic whirlpool. Material from this disk continuously falls onto the protostar, adding to its mass. This phase can last anywhere from 10,000 to 1 million years. An eye blink in cosmic time, but an eternity by human standards. During this phase, something dramatic also happens. The protostar begins shooting out powerful jets of gas from its poles. These jets, called bipolar outflows, blast material away from the star at tremendous speeds, often carving out beautiful structures in the surrounding nebula. If you've ever seen those stunning images from the James Webb Space Telescope, those spectacular jets and glowing structures, that's exactly what we're talking about. As the protostar grows, the pressure and temperature at its core keep climbing. It needs to reach one specific threshold to become a true star: 10 million degrees Celsius. That's the ignition point, the moment everything changes. When the core temperature finally hits 10 million degrees, nuclear fusion begins. Hydrogen atoms, moving at incredible speeds in the superhot core, begin smashing into each other with enough force to fuse together. Two hydrogen atoms combine to form one helium atom, and in that process, a tiny amount of mass is converted directly into energy. Pure, raw energy. This is the same process that powers hydrogen bombs, except in a star, it's happening continuously in quadrillions of reactions every single second. The energy release creates an outward pressure, pushing against the inward pull of gravity. And when these two forces balance perfectly, gravity pulling in, fusion pushing out, the star achieves what scientists call hydrostatic equilibrium. It stabilizes, it shines, it becomes a main sequence star. A new sun has been born. Our own sun went through this exact process about 4.6 billion years ago, inside a stellar nursery that no longer exists. Every single photon of sunlight that has ever touched your skin began its journey with a nuclear fusion reaction in the heart of a star. Let that sink in. Not all stars are created equal, and what determines a star's size, brightness, color, and ultimate fate is decided right here during its birth. The single most important factor: mass. How much gas the protostar collected during its formation. Low mass stars, like red dwarfs, burn cool and dim, but they live for trillions of years. The universe isn't even old enough to have a single dead red dwarf yet. Medium mass stars, like our sun, burn for about 10 billion years, then expand into a red giant and end as a white dwarf. High mass stars, the massive blue giants, burn ferociously hot and bright, but live for only a few million years before dying in a spectacular supernova explosion. And here's the poetic twist. When those massive stars die in supernovas, their shockwaves travel through space and trigger the birth of new stars in nearby nebulae. The death of a star gives birth to new stars. The cycle continues forever. Thanks to modern telescopes, especially the James Webb Space Telescope, we can now see stellar nurseries in stunning, breathtaking detail. Here are some of the most famous. The Orion Nebula, just 1,344 light-years away. It's one of the closest stellar nurseries to Earth. Visible to the naked eye on a clear night as a fuzzy star in Orion's sword. The Eagle Nebula, Pillars of Creation, one of the most iconic images in astronomy. These towering columns of gas and dust are actively forming new stars right now, as we speak. The Carina Nebula, one of the largest and brightest nebulae in our galaxy, containing some of the most massive and luminous stars known to science. The Tarantula Nebula, located in a neighboring galaxy, this is the most active stellar nursery in our cosmic neighborhood, forming stars at an explosive rate. Every time the James Webb Telescope points at one of these regions, it reveals new stars being born that were previously hidden behind clouds of dust. We are literally watching the universe create new suns in real time. Stars aren't just objects in the sky. They are the universe's greatest achievement, born from chaos and gravity and heat, nurtured inside cosmic clouds for millions of years, ignited by the most powerful force in nature. And every atom in your body, the carbon in your cells, the oxygen in your lungs, the iron in your blood, was forged inside a star that lived and died long before our sun was even born. You are not just watching the stars, you are made of them. If this video gave you that feeling, that incredible sense of wonder, please like and subscribe because we explore these deep questions every week. Comment below, which part of star formation blew your mind the most? Until next time, keep looking up.